three forces F1, F2, and F3 in newtons acting on a mechanical system satisfy the following simultaneous equations. The equations are here. We have F1 minus F2 plus F3 equals to 4. Then we have 2F1 plus F2 plus 3F3 equals 25. And then we have F1 minus 2F2 plus F3 equals to 0. So they want us to use Cramer's rule to find the values of F1, F2, and F3. Solution. The first thing for us, we shall use X and Y and Z. It's easier to work with X, Y, and Z rather than F1, F2, and F3. So what we shall say here, let X equals to F1, Y equals to F2, and Z equals to F3. So once we do that, then we can now replace the given equation. In that, then we shall have X minus Y plus Z equals to 4. And then this equation becomes 2X plus Y plus 3Z equals to 25. And then here we have X minus 2Y plus Z equals to 0. So these are our simultaneous equations. Now for us to use the Cramer's rule also uses the determinants. Therefore, we shall write this equation as X minus Y plus X minus 4 equals to 0, and 2X plus Y plus 3Z minus 25 equals to 0. And then we have X minus 2Y plus Z, then plus 0 equals to 0. So once we have this, then we have this is the formula we are going to apply to solve this equation. It will be X over del 1 equals to minus Y over del 2, which equals to Z over del 3, which equals to 1 over. This is minus, the sign also is positive, negative, positive, negative. Therefore, once we have done this, so we need to find the value of del 1, del 2, del 3, and del 4 like that. So once we get the values, then we just insert in this equation, then we shall be able to get the values of the unknown. Okay, now for us to get this del 1 equal to, we now plug the coefficients of X. So for us to get the del 1, then we avoid the coefficients of X and now write the coefficients of these other coefficients. Therefore, if I avoid X, then I'll have, here we have negative 1. So I have negative 1. This is negative 1. This is positive 1. Then this is negative 2. Then for Z, there is the coefficient is 1, the coefficient here is 3, and then the coefficients here is 1. Then here we have negative 4, negative 25, and then I have 0. So we now expand the determinant of this for us to get del 1. So this equals to, of course, we shall have minus 1 into, now plug this column and this row so that we have 3, negative 25, we have 1, then 0, like that. Then of course minus 1, we on this second element, we block this column and block this row, so we remain with 1, negative 25, 1, negative 25, and then negative 2, and then 0. And then lastly, we have this, so it will be minus 4 into block this column and this row, so we have 1, 3, and then negative 2, and then 1, like that. So once we have done this, so what we do is now for us to expand again. So this equals to, we are now here, it will be 0 times 3. Of course, we have 1, negative 1. 0 times 3, we have 0. Then minus negative 1 times negative 25, we get negative 20, negative 25. Then we are here, negative 1 into 0 times 1, we have 0. Then minus negative 2 times negative 25, we get positive 50. So it will be minus 50, then we are here, negative 4 into 1 times 1, we have 1. Then minus negative 2 times 3, we have negative 6. Therefore, this equals to negative 1 into, this will now be 5, minus 1 into, this will be minus 50. Then you have minus 4 into, this will now be 7, like that. So this equals to negative 25. Negative 1 times negative 50 plus 50. Then we have negative 20, 27, negative 27. So this equals to 50 minus, this is 28, negative 4 times 7. Therefore, we have 50 and negative 25 plus negative 28, we get negative 50, negative 53. Therefore, this equals to negative 3. So what we are saying is that del 1 equals to negative 3. Now move on and calculate. We now have this. We now need to get del 2. Del 2 will be equal to, now del 2 we are going to omit the coefficients of y. Therefore, we shall have 1, 2, 1. So we have 1, 2, 1. Those are the coefficients of x. Then the coefficients of z, we have 1, 3, and then 1. The coefficients of z, we have 1, 3, and then 1. Then the coefficients of the constants, we have negative 4, negative 25, then we have 0, like that. So we do this, then we expand the determinant. So this will be equal to, of course, this is 1. Then we plug the column and the row, so we have 3 minus 25, and then 1, 0, like that. And then we have minus 1 into block this column, this row, so we have 2, negative 25, 2, negative 25, then we have 1, then 0. Then lastly we have negative 4 into block this column and this row. So we have 2, 3, 1, 1, like that. So this equals to, now need to do expanding here, so we have 1 into 0 times 3, 0, then minus 1 times negative 25, we have negative 25, so minus 25, then minus 1 into 0 times 2, we have 0, minus negative 1 times negative 25, we have minus 25. We are here minus 4 into 1 times 2, we have 2, minus 1 times 3, we have 3, like that. So this equals to 1 into, so this will be positive, minus and minus, we have 5, then minus 1 into, this will be positive, so plus 20, 25, then we have minus 4, 2 minus 3, we have negative 1, where here we have 4 in negative 1, so this equals to, this will be 25, minus 25, minus 25, then negative 4, so we have plus, we have 2, 3, 2 times that, we have 2 minus 3, we have negative 1, so we have here negative 4 times negative 1, we have plus 5. Therefore, this equals to plus 6, is equals to L2, just a minute. Let us see, let us see, we have L2, so we omit the coefficients of y, so we have 1, 2, then we have 1, then we have 1, we omit y, so we have 1, 3, and then 1. So here we have 1 into 3, negative 25, 1, 0, that's correct. Then we have minus, this is x means z, which is positive, so we have minus 1, so we block that, so we have 2, negative 25, 1, 0, that's fine. Then of course we have minus 4, yes, into we have 2, 3, 1, 1. Okay, that's fine. So we have 1 into 0 times 3, that is 0, and then minus 25, that is fine. Then minus 1 into 0 times 2, 0, then it will be 1, 1, that's fine again. Then lastly 1 times 2, we have 2, minus 3, so that's fine. So we are saying that L2 equals to 5. L2 equals to 5. So once we have L2, we can now find day 3. Now find day 3. Okay, day 3 we are going to omit the coefficients of z. We omit the coefficients of z. We omit the coefficients of z. So we are going to have 1, 2, 1, 1, 2, 1, and then you have negative 1, you have 1, and then you have negative 2. Omit the coefficients of z, so we made the constant terms, minus 4, minus 25, then 0. So at this point, we again expand the determinant, so we shall have 1 into, so we have here, we have 1, negative 25, negative 2, 0, then we have minus 1 into, plug that column on that row, so we have 2, 25, then 1, 0, like that, and then lastly we have minus 4 into 2, 1, 1, negative 2, like that. And then we expand this, so we have 1 into 0 times 1, 0, minus negative 2 times negative 25, so we have minus 50. Then this will be plus 1 into 0 times 2, you have 0 minus 1 times 25, minus 25, minus 4, we are here, into negative 2 times 2, we have negative 4, then minus 1 times 1, like that. So this equals to 1, so this is minus 50, then this will be minus, so we have 0 minus that, so we have that 0. So that's positive, so 1 minus, so we have minus 50, then 0 minus, we have that, so we have 2, this is negative, this is negative 25, this is negative 25, negative 25, that is so negative 25, this time that 0, so this will be plus, because we have 0 times 2, we have 0, minus 1 times negative 25, minus will be positive, like that. So we have plus 25, and then negative 5 times negative 4, so we plus 20. So plus 20, therefore this equals to negative, this is 45, so this is negative 5. So day 3 is negative, day 3 is negative 5, day 3 was negative 5. Then move on to so this equals, now we omit the constant terms, so that will remain 1, 2, and then 1, minus 1, you have 1, then you have minus 2, then you have 1, you have 1, 3, then you have 1, like that. You expand the determinant here, so you have 1 into 1, 3, negative 2, 1, then minus 1 into, plug that column on that row, so we have 2, 3, 1, 1, then we have plus 1 into 2, 1, 1 minus 2. We expand this, so we have 1 into 1 times 1, we have 1, minus negative 2 times negative negative 2 times 3 we have negative 6. This will be plus 1 into 1 times 2. We have 2 minus 1 times 3. We have 3. Then plus 1 into negative 2 times 2. Negative 4 minus 1 times 1. We have 1. So this equals to, of course, this will be 7. 1 minus 6, it will be 7 times 1, we have 7. 2 minus 3, negative 1 times 1, we have minus 1. Negative 4 minus 1, we have negative 5 times 1, we have negative 5 minus 5. So this is equals to 7 minus 6, which is equals to 1. Therefore, we have del not equals to 1. Now, before we proceed, I want us to confirm del 2. We say that del 2, we omit the y coefficients. So we write, we have 1, 2, 1, and then we have 1, 3, 1. We are using this, so we have that to omit 1, so we have 1, 3, 1, 1, 3, 1, and then the constant coefficients, the constant terms we have negative 4, negative 25, then we have 0. So for us to expand the determinant, we have that. So we have 3, negative 25, 1, 0. Then we have minus 1 into log part, and that's so we have 2, negative 25, 1, 0. Then we have plus minus 4 into 2, 3, 1, 1, like that. So we expand this, we can have 1, 0 times 3. We have 0 minus 1 times negative 25, we have negative 25. Then minus 1 into 0 times 2, we have 0 minus 1 times negative 25, we have negative 25. Then minus 4 into 1 times 2, we have 2, minus 1 times 3, we have 3. So this equals to minus and minus is positive here, so we have 25. Minus and minus, so this is positive, so we have positive, positive. So we have minus 25. Then minus 4 into this negative. 2 minus 1, 2 minus 3, we have negative 1 times 4. Yeah, we have negative 1 times 4, so we have positive 4, like that. So this equals to 4. So the 2 is not 5, this is 4. Okay. Therefore, once we have del 1, del 2, del 3, and del not, we can now move on and start finding the values of unknown. We can start with this one. Say that z over del 3 equals to negative 1 over del not. So, but what is our z? Our del, when we are dealing with the z, so del 3 is negative 5, so this will be negative z over 5 equals to negative 1 over del not is 1. Okay, the negative and negative will cancel out, so we have z over 5 equals to 1. So we multiply both sides by 5, by 5. So z equals to 5. So once you get the value of z, you can now come and get the value of y. Minus y over del 2. Del 2 is 4. This one equals to z over del 3. So z is 5 over del 3. Del 3 is negative 5. So this negative 5 over 4 minus equals to minus 5 over 5. So this negative will cancel out, and then you have y over 4 equals to 1. So you multiply both sides like that. So y equals to 4. Y equals to 4. So we come here. We have x over del 1 is negative 3. So we can say negative x all over that must give us negative y. Y is 4, so it will be negative 4 over del 2, which is 4. This negative and negative will cancel out, so that we have x all over 3 equals to 1. Multiply by 3 on both sides, 3, 3. So we have x equals to 3. Okay, now we can collect the findings. So we are saying that z equals to 5, y equals to 4, and then x equals to 3. So we can still confirm whether this one is correct or not by using, for example, x minus y plus x equals to 4. Let us prove that what we have gotten is right. So x is 3 minus y is 4, then plus z, which is 5. I say that this one must give us 4. Let us see. This plus that. 8 minus 4 is equals to 4. That's correct. Let's confirm the last equation. X is 3 minus 2y, y is 4. Then plus z is 5. I said that it must give us 0. Let us see. 3, 2 times so minus 8 plus 5. That's okay. Let us confirm the middle equation. 2 into x is 3, plus y, which is 4, then plus 3z, z is 5. Must give us 5, let us see. 2 times 3 is 6, plus 4. 3 times 5, 15. 2 plus 6 plus 4, 10 plus 15, 25. So that's okay. Now, but remember, in our equation we didn't have x, y, and z. We now go back and substitute. So from here we can now substitute. So our F1 will be equal to x, which is 3 newtons. Our F2 will be equal to F2 was y equal to 4 newtons, and then F3 z equal to 5 newtons. Thank you for watching and listening.